Okay, at this point, we've gone through a few different examples and I'm ready for you to start trying these on your own. However, if you look at page 473, the try these B, that section, if you look at problem B, you'll notice this one is slightly different from the other ones we have looked at. This one has a negative sign in front of x squared. So I wanted to do an example like this to show you how to work it out and what to do with that negative sign and what it means, okay? Now, just looking at it, if x squared is negative, that's your a value. When a is negative, what does that tell you about the quadratic? Well, that tells you that it opens down, okay? So you already know that about this function. But we're going to get a little bit more information. We're going to put this quadratic in vertex form, and we're going to use the method of completing the square. Okay, so following the steps from before, I'm going to first take the quadratic, and instead of it being set equal to y, I'm going to set it equal to 0. Okay, I'm going to set it equal to 0. The next thing I'm going to do is I'm going to isolate my variable term. So I'm going to take this negative 8 and I'm going to move it to the other side of the quadratic by adding 8 to both sides. Okay, so I'm adding 8 to both sides. That 8's going to become a positive 8 when I move it over to the right-hand side. Okay. Now at this point, if we just look at the left-hand side of the quadratic, you'll notice that both terms are negative. Okay. Even if only the first term is negative, it's very helpful to actually factor out that negative sign before we start completing the square. Okay. So we're going to factor out the negative sign, and in parentheses, we're going to have x squared plus 6x, and then we have equals 8. All right. The next step is where we're actually going to start completing the square. Okay, so this is where we complete the square. Complete the square. All right, so I'm bring down my negative sign. In my parentheses here, I've got x squared plus 6x plus something. And we're going to have equals 8 plus something. Okay. All right, so let's complete the square. B divided by 2 squared. B in this case is a positive 6. 6 divided by 2 squared. 6 divided by 2 is 3, and 3 squared is 9. So to make my perfect square trinomial, I'm going to add a 9, okay, into my quadratic. Now this part is where students kind of forget this little step right here. When we go to add the 9 to the right-hand side over here, we have to remember that we factored out a negative sign. Okay, if that negative sign was still in here, this 9 would be negative. So when we add the 9 to the right-hand side, we're actually going to add a negative 9. It's going to be a negative 9. Think of it as like you're multiplying it times whatever you factored out of the quadratic already. Okay, so we're putting a positive 9 here because think about it, if I distribute, that 9 is going to be negative, right? So therefore, on the right-hand side, I need to put a negative 9 right here in the blank. Okay? Same steps as before. Let's bring down our negative sign. We have a perfect square trinomial, so let's factor it into a binomial squared. I need factors of 9 that add up to 6. Factors of 9 that add up to 6, that would be 3 and 3. So I'm going to have x plus 3 squared equals, right here I've got 8 plus negative 9, that gives us negative 1. Okay, now let's write this in a form that's a little bit more familiar. That's our vertex form. I'm going to go ahead and bring back y equals. I'm going to bring down all of this left-hand side of my quadratic. Okay, so negative 1, it's like a negative 1 times x plus 3 squared. Okay, now imagine you took this negative 1 and you moved it to the other side, which we did. We're just not showing that step, okay? That's going to give us a positive 1. So this would be a plus 1 right here in our vertex form. Okay. All right. So we have our quadratic. We completed the square. We put our quadratic in vertex form. Remember that vertex form is y equals a times x plus h squared plus k. Sorry, this isn't a plus sign, this is a minus sign right there. Sorry about that. X minus h squared plus k. Okay, so this problem asks us to do several things. It asks us to identify, number one, the direction of the opening. That's asking us, does it open up or does it open down? Now, when the quadratic was in standard form, we could already tell that it was going to open down because a was negative. And once again, you can tell in vertex form because of this negative sign that's right here in front of the parentheses. So this is telling us that our quadratic is going to open down. Okay, we're opening down. Then we want to know where's the vertex of our quadratic. Well, vertex is HK. So HK from our quadratic, remember H and K right here. So these two numbers are the numbers that we're going to pull. Remember, it's going to be the opposite sign of whatever H is. So if H is a positive 3, when we go to write our vertex as an ordered pair, we're going to put negative 3. And our K, or our Y value, is a positive 1. So that's where our vertex is located. Okay, I'm going to graph that for you right here. So negative 3 and positive 1. All right, and let's think about it. If it opens down, then that means our quadratic is going to look something like this. All right, next it's going to ask me, is our vertex a maximum point or a minimum point? Well, if it opens down, then that tells us that we have a maximum value. Where's our max located? It's located at the vertex right here. Okay, and then we also want to know how many intercepts do we have, and of course they're referring to, these are x-intercepts. We want to know how many times does this quadratic touch the x-axis? Well, this one touches twice. Okay, we can kind of eyeball where they are. We could go ahead and finish, we could use square root method and finish solving this quadratic to figure out the exact points, but that's not what they're asking us here. They just want to know how many intercepts do we have. We have 2 intercepts. Okay, your options for the number of intercepts would be 1, 2, or 0. 1, 2, or 0. Okay, we've already seen one where we had 0 intercepts. This is one where we have 2 intercepts. We haven't seen one yet with just 1 intercept, but I bet we will. Okay, all right, next thing I want you to do is I want you to do try these B. Okay, whoops. Try these B. I want you to do A and C, all right? And I will have worked examples for you. It's just going to be a picture of my work, and you can pull it up and check your work to see how you did on those.